we're going to be doing 10.1 today. Developing formulas for triangles and quadrilaterals. Developing formulas for triangles and we'll call that a quadrilateral. Okay. Can anybody tell me what a quadrilateral is? First of all, before we even get started, what's a quadrilateral? Well, a four-sided polygon. Okay, so it's a polygon that has four sides, right? Can you tell me what a polygon that has five sides? Pentagon. The next one, hexagon, right? 7. It's a heptagon. Did you say heptagon? Heptagon. I think it's a heptagon. 8. Octagon. We all know that one, huh? Okay. And then there's a nanogon. Or is it? I don't know. I don't even know. Okay, whatever. Okay, so let's talk about this. We have a postulate on page 677. Area of a region is equal to the sum of the areas of its non-overlapping parts. Okay, so I guess what that means is that you can take a shape that looks like this, and you can cut it like this and say the total area is this guy plus this guy plus this guy. Non-overlapping parts. Okay, right? Area of a parallelogram. Area of a parallelogram. You guys have encountered this before, I'm assuming, correct? Where the area of this parallelogram is what? Anybody know? Anybody remember? It's the same as a rectangle. What is the area of a rectangle? Base times height. So this is also base times the height. Okay. You look at this two ways. The way the book tells you is that you can take, since these two are parallel, I can take this triangle, cut it off, and actually put it back up here. Okay. So now I have a shape that actually truly is a rectangle, and it's base times height. Correct? Another way to look at it is let's say that if you can imagine a rectangle that looks like this, that is basically a stack of paper, and I push it from this side. Can you see just everything shifting across? So that it looks like this now, and it's a parallelogram, but it still has the same area. You will encounter this again for those of you who end up in my calculus class. We will talk about this again. Okay, but it is kind of like you shove it over. You have it, you kind of tilt it over. It's like a stack of, if you had a stack of CDs in a cylinder, you kind of just tilt it over. The volume or the area looking over here stays the same. Okay, let's look at example number 1. Example number 1. Find each measurement, area of the parallelogram. So we're trying to find the area of the parallelogram. What are the two things we need to know to get the area of the parallelogram? The base and the height. Okay, so let's look at this picture and see if we can figure that out. 6, 5, 3. So out of the base and height, what do we know? We know the base. The base is this guy right here. I just need to figure out the height. Okay. So the height would be this guy right here. Okay. How can I figure out that?
Pythagorean theorem.
The Pythagorean theorem. 5 squared is equal to 3 squared plus h squared. 25 is equal to 9 plus h squared. 16. H will be 4. So it's going to be equal to 4. So this is going to be equal to 4, which means that now the area is nothing more than this times this. 24. And move on to the next one. Height of a rectangle. This would be B. The height of a rectangle in which B is equal to 5 and A is equal to 5x squared minus 5x. So B was equal to 5. Area of a rectangle was base times height. And this just happens to be this guy. And I want to know what the height is, right? I want to know what the height is. So I know this guy is 5, so I just put this guy in here. Try to solve for h. Simple, just dividing by 5 on both sides. H is going to be equal to x squared minus x. Okay. Do we get that? This guy and this guy, right? X squared minus x. Another way to look at it is that this is, I can pull the 5s out because they're shared and go like that. All right. And then this would be, and if I divide both sides here, if this is 5h, divide both sides by 5, same result. Okay, that would be, let's do C. The perimeter of the rectangle, which the area is equal to 12x. Area is equal to 12x, and one side we know is given to us by 6. Okay, I don't know this guy. Okay, but I know the area in the end is going to be equal to, area is going to be equal to this times this. And that was equal to what? 12x. And I want to solve for W, right? So what would I do? Maya? Sophie?
Like 12x equals 6w, and then
I'm trying to solve for the W.
yeah, and then you can divide 6.
Divide 6 by both sides, right? This will cancel out. W is going to be equal to this. So, but I can also say this. W is equal to 2x. In other words, this guy here, I know now is 2x. And we're trying to find the perimeter. Okay, so the perimeter is this plus this and this plus this. Right? Correct. All right, so let's go in the middle of page 678. Middle of page 678. There's another new formula for us. There's the area of a triangle, area of the trapezoid. Area of a triangle is always going to be easy for you guys. You have been drilled about this for quite a bit. The area is going to be equal to 1/2 base times height. The one that you're going to struggle with and always forget is the trapezoid. Okay, trapezoid. So if I have trapezoid that looks like this, this is B1, B2. This is the height. Area is going to be 1/2 B1 plus B2 times the height. A little complicated equation. Okay. I will tell you the way to remember this so you don't have to memorize it. Okay. If I took this guy, copied it, so now I have two of them, and I stacked them one by one, but I stacked them such that it looks like this. Can you see two congruent trapezoids there? Right? I just took this guy, rotated it around, and just put it together. Right? What do I have? What kind of shape do I have now? The total thing. Can you see that it's a parallelogram? Right? It's a parallelogram. What was the area of the parallelogram? Base times the height, right? What's my base now? Because this is B1, that means that this guy is B1, this is B2. So now my base is going to be B1 plus B2. Multiply that by the height. That is the area of the parallelogram. But I want to know what the area of the trapezoid is, and it's actually going to be exactly 1/2 of that. Because I have two of them, right? I only want to know the area of one. Same thing. Right, you see that? Okay. So this comes in quite handy to understand where this came from, okay, rather than trying to just memorizing this. Yep. It's actually the same thing with the triangle, just in case you were wondering. Triangle is a little different, but it's kind of the same idea. Base times height. If I actually put this into a rectangle, it's going to look like that. Can you see that this triangle and this triangle are the same? And by the same token, this triangle and this triangle are the same, which means that the triangle has to be exactly 1/2 of the rectangle's area. Right? And the rectangle's area here is going to be B times H. So triangle to be 1/2 of it. Right? We'll do this again today. Soon, quite soon here. Let's go ahead and do example number 2. Example number 2, finding the measures of a triangle, the area of a trapezoid in which B1 and B2 and H. So this is simply a plug and chug. You plug the numbers in, just go ahead and chug the answer out. So the area is going to be 1/2 of B1, B2 times H. 1/2 B1 plus B2 is 21. Height was 3. Right? So it's going to be 63 divided by 2. 31.5. B, the base of a triangle in which A is equal to x squared. So A, B, the area is equal to x squared, and you have a triangle. It looks like this, where the height here is x. And I have B here. So I look just as this, as just if I look from this side, from this point, my area is going to be 1/2 base times height. But that is equal to x squared. I'm told it's equal to x squared. I'm trying to find the base, is it? The base? I'm trying to find what B is here. Okay. Evan?
Oh, yeah, I can't really do it.
Okay, that's okay. Bx is equal to x squared. We're trying to solve for B, right? So I'm going to isolate B. So the first thing I would do is multiply both sides by 2. Right? I'm trying to solve for B, so I divide everything by x. So one of these x's goes away, and one of the x's goes away. B is equal to 2x. C, B2 of the trapezoid in where the area is 8. Okay, so it's a little bit of backwards now. So we're going to still use this guy. C. B1 is what there? Kayla, what is B1 there? They gave us B, no, we're trying to solve for B2, but they did give us B1. Which one is B1? What is the other leg?
Would be 3.
3, right? So we have 1/2, 3 plus B2 times the height. What's the height? Kayla, continue on. What's the height?
8.
No, that's the area, isn't it? What's the area? What's the height? Look at the picture. 2, right? And when I do this, the area is supposed to be 8. Right? Belen, solve this for us.
So then you pretty much times 2 by
1/2. It would just cancel out, wouldn't it? So you end up with 3 plus B2 is equal to 8, which means that B2 would be equal to, if I move the 3 over, it would be 8 minus 3. 5, right? Okay, so let's move on to the area of the rhombuses and kites. Does anybody know what a rhombus is? You heard the term before. This is where you all raise your hand. You've heard the term rhombus before, correct? You've done this. You've done this in pre-algebra. I remember when I used to teach pre-algebra. We did this. So rhombus is where you have all sides are the same. So basically what you're doing is you're taking a square and you're squishing it, right? You took a square and you're squishing it from 2 points. So these are no longer 90 degrees, where a square would be 90 degrees, right? So if this diagonal is called D2 and this diagonal is D1, the area is going to be 1/2 of D1, D2. The way you remember this is just as we did with the triangle. We're going to put this into a rectangle. Okay, so the area of the rectangle is D1 times D2. And the rhombus is going to be exactly half of that. Because this triangle are the same, this triangle and this triangle are the same. Here the same, here's the same. So it's half. Does that make sense? Okay. By the same token, if I took this D1 and I slightly moved it over here, now I'm going to come up with a shape that looks like that with a D1 and a D2, right? And the same thing applies here because this triangle are the same. I'm looking at the purple one now. This triangle are the same. These two are the same. These two are the same, right? The only difference is the purple one is no longer a rhombus because the sides are not equal. It's called a kite. Okay. And that's on page 679, the little bottom portion, the kite. There's a long-standing debate among teachers, whether, or mathematicians for that matter, whether a kite is truly a shape. Is it even worth discussing? Whatever. Okay, just letting you know. So again, both of those are 1/2, the area is 1/2 times the diagonals D1 times D2. Okay. All right, let's do example number 3. We have a D2 of a kite, which D1 is 16 and A is 48. So the area where the equation for this rhombus, it's a kite. Okay, where A is equal to 48, 1/2. He gave us D1 as 16. And I need to find out what D2 is. 8. Right? 8 times something is 48. So obviously that something has to be 6. Here, so D2 would be 6. Remember, what's the page? Go to B, area of the rhombus. Area of the rhombus. So this is a little trip through memory lane for you guys. See if you can remember your Algebra 1 skills. Area rhombus, where D1 is 6x minus 4, plus 4, I'm sorry. That's D1 times D2, where D2 was 10x plus 10. You divide that by 2, and that is the area, and you are given the area, or are you just trying to find a... Okay, all right, so this is the area, right? So I need to figure this out. Okay. Reeve, how would I do this? You actually caught Reeve sleeping? Reeve, are you there?
Yeah, I'm just trying to figure it out.
Oh, okay, you're not sleeping. Okay, good. You would just have to do these out, right? Expand this out. Okay, so do you know how to do that?
We just multiply them together, so it'd be like 60 and then plus
60,
100.
what? 60, what about the x's? The x's go away?
Keep the x's.
How
Yeah,
many are there?
60x, and then x squared.
Okay, x squared. And then I go from here to here, right? What is that?
60.
Well, how many x's?
Same thing, x squared. No, just 1x.
That's 1x. Then I do here from here. What do I get there?
You get 40, but there's no x's.
Yes, there is. There's one right here, 40x.
Oh,
From here to here, what do I get?
40.
40.
That one, no x's.
Now, are there any like terms here?
Yeah, you combine the x's.
Okay, how many do I have altogether?
So 60x squared plus 100 plus 40, or 100x plus 40.
What?
Like in the middle there, you combine 60x plus 40x.
Two terms, right? We get 100x, right?
Yeah.
Okay, that's all we can do. All right. Now I have to get rid of the half because it's kind of ugly looking in front of it. So I'm going to go ahead and distribute the half out. 30x squared, 50x plus 20. Thanks, Reeve. Okay, so that's how it would work. Okay, you good with that? Remember the, I think the term that you use, if you learned this in, was like FOIL or something? Use the FOIL method, is that what you were taught? No? Okay, whatever. All right, so that's that. And then we have C, the area of the kites. This is interesting. A kite. Who's yelling? Okay, so I have a kite that looks like this, 41, 9, 15, 41, 9, 15, X and Y. And I want to know the area of the kite. So the area of the kite is going to be equal to 1/2 this diagonal times this diagonal, right? Okay, so I need to find out what X and Y are and add them together to find this diagonal. How can I find X? Yeah.
Do 9x plus x equals 49.
Hmm.
Oh,
Would we just do the Pythagorean theorem here from this triangle? Right. So it'd be 41 squared is equal to 9 squared plus x squared. Okay, so 41 squared is, anybody memorize this? I don't. This is 1681. I do want to know what 9 squared is. That is 81 is plus x squared. Move this over, I subtract 81 out. Oh, look at that. Isn't that special? So what's my x? What squared is 1600? 40, right? Way to do this so you would square root it, right? Square root of 1600 is equal to square root of 1600. 4, 40. So x is going to be equal to 40. So I found x. X is 40. That's good. What about y? You have to remember that the diagonals in a rhombus or a kite will bisect each other, right? So they cut them in half. So not one in a rhombus, but over here, so this guy is half. So this guy is 9 also. Okay. So what is y? Again, 15 squared is equal to y squared plus 9 squared. 15 squared, anybody? No takers on 15 squared? Okay. Again, it's 81. So I move it over, subtract the 81 out, I get 4a41. Any takers on square root of 144? 12, right? So it's going to be 12. So your y is going to be equal to 12. Therefore, I found one guy here. What is that? That is x was 40 and y was 12. That was D1. Z2 is going to be equal to 18. 9 plus 9, 18. 9. 52 times 9. Is that the correct answer? Yep, 468. Okay. Okay, example number 4, the last one. Pieces of a tangram are arranged in a square, which is S. The side is 4 centimeters. Use the grid to find the perimeter area of the red square. So if the sides, each sides are 4 centimeter in that total square, each grid is what by what? 1 by 1, right? Because there's 4 on each side. They're squares, so it's 1 by 1. So if you look at that red thing there, you have 1, 1, 1, 1, right? So you can look at this 2 ways. You can look at this as a rhombus and say the area is 1/2 2 times 2. And you can get 2, right? Another way to look at this is actually a what? This is actually a square now, right? It's a square. Can you notice that? You see that this would be 90 degrees, these would be 90 degrees. Right? It's a square, so it's the side. If I know one of the sides, I can figure that out. 1 to 1, square root of 2. It's a 45, 45, 90 degree triangle. So one of the sides is this, so the area would be this times this. Two. You get it that way also. Did you ask for the perimeter too? Find the perimeter. The perimeter would be this plus this plus this plus this. So there are 4 of these. 4 root 2. Okay. Any questions there? Any questions? All right, let's go ahead and get started on the homework then.